This is covering 7.2, difference of proportions, but we're in the unit where we're talking about sampling distributions of proportions as well. And this is page 7 of the guided notes that you should see on Canvas. All right, so here's our situation. Mr. Jones is the teacher next door to me, and we were just talking about Skittles and M&Ms. And I like the orange Skittles the best. And anyways, weird conversation, but I believe that Skittles have a higher proportion of orange candies than M&Ms. Whenever I eat the M&Ms, I feel like there's like tons of brown, and those are my least favorite because they're not as exciting, of course, right? As far as M&Ms go, right? We don't have that issue with Skittles. But Miss Beast believes that Skittles have a higher proportion of orange candies than M&Ms, while Mr. Jones believes the opposite. Who is correct? So, in class, they will be given 50 Skittles and 50 M&Ms. They're going to have to count them. So, if you have a second, go grab a bag of Skittles and a bag of M&Ms. There should be about 50 in there, typically, and then you can count them. But I had a bag of Skittles, and there were 13 out of 50, which is 0.26%. This is a sample, right? So I'm going to use p hat of Skittles, so my sample proportion. And then the M&Ms, I had 50 as well, and there are 9 out of 50, which is 0.18. So that's again a p hat for M&Ms. Now the difference, I specified I want to do Skittles minus M&Ms. So when I do that, I get 0.08. Okay, so write the difference on a sticker dot and place the dot on the board. We did this, and I'm going to use my data from last year. They had 1 here, 3 here. So if you'll just copy this down so you have an idea of it, since you don't have access to lots of people probably, and buying them Skittles and M&Ms. So copy this one down. We had a lot of people that had 0 actually, right? And then we had, let's see if I can line those dots up. Okay, and then we had 2 here, and 1 here, and then we had 1 here. All right. So this is the distribution that I got for, like I said, one of my classes last year. So what does each dot on here represent? I want you to think about that. What is that dot actually telling us? And the title's going to give us a hint, right? But it's the difference. So exactly what I did on the very, very first problem under 15. It's the difference in proportions of orange candies for one sample of Skittles and M&Ms. Okay, and so just kind of notice, since I did Skittles minus M&Ms, if I got a positive number, that meant that there were more Skittles, right? And if I got a negative number, that was the scenario where there were more M&Ms. And then if we got 0, obviously they had the exact same percentage. So just kind of think about that, what each dot represents, right? Okay, so what I want you to do is do 18 real quick. Just your best guess at that, okay? So if you want to take the time to actually calculate what's the true mean, the shape, we're just going to kind of eyeball that, but I mean, you could argue it's fairly symmetric, though. I mean, we need more samples to really see the shape, but I'm going to just say that this is approximately normal. It's pretty close, right? We really don't have enough data to make a claim yet. All right, the center, I'd say it's between 0 or 0.02, if I had to take a guess. But again, if I really want to know, I could add all those up, divide by how many there were. I'll leave that to you if you'd like to. And the variability, so if I kind of look at what most of the data, the typical distance that the data is from the mean, I'm going to guess 0.06. So just estimating here, nothing really official. All right, so we created a sampling distribution. It's not a true sampling distribution because we don't have every sample. There are tons of M&Ms and Skittles in the world, and we do not have a way to sample all of them. Okay? All right. So here we have the true, sorry, wrong symbol. Oh, that was mean, right? And I'm obviously working with proportions. We have the true proportion of Skittles at 0.216, and we have the true proportion of M&Ms at 0.2. So my samples right now are kind of pointless because I actually do have the true parameter here. But we're going to look at similarities between our sampling distribution that we just created and then the true parameter there. So first we're going to look at them individually. So this is saying that you have one sample of each, right? So one sample of Skittles. If I know the true parameter, I can find this shape, okay? And I'm going to tell you it's approximately normal. So I want you to think, if you know the parameter, how are you going to know the shape? I also know the mean of my sampling distribution. So the average sample proportion for Skittles, I can figure that out, if you remember. So take a look at the formula sheet, and then I can find the standard deviation of my sampling distribution because I know the parameter, okay? All right, so how do you know the shape? How do I know that it's approximately normal? The rule here is large counts, all right? And think about what that means. The mean of my sampling distribution, like I just guessed on the last page, right? But because I know the parameter, I'm going to know if I would have been able to take all the samples possible, then the mean of all those proportions would be that parameter, okay? And then my standard deviation, if you remember, will be p times 1 minus p all over n. So I'm going to go ahead and calculate these. So remember, large counts rule is your sample size times your p, which is your proportion. And if it was greater than or equal to 10, but also the opposite there, the opposite proportion is also greater than or equal to 10, it's approximately normal. Okay, let's look at M&Ms. So we also had a sample size of 50, but we had a little bit different proportion. And so that barely gets us by, right? Okay, and the other one goes like this, which is 40. Okay, so again, the point of this is if I were, so describe the sampling distribution of the sample proportion of orange Skittles. So if I were to go and sample all the possible sample size 50 of all the Skittles, this is what the shape would be. Like I'd have tons of dots, not what I just created, but tons and tons of those dots representing a sample, right? And it would be normal, and it would be 0.216 would be my center. If you remember, we have an unbiased estimator if we do everything correctly, and so we're good to go. And then as I put these numbers in, 0.216 times 0.784 divided by 50, take the square root of that, I get 0.0582. Okay, and then the mean of my proportions, my sampling distribution proportions for M&Ms is 0.2. The standard deviation for all those guys, for my M&Ms, is 0.0565. Okay, so we're going to make this transition. So we have these two separate, right? So we have these two separate sampling distributions. We're going to see what happens when we try to combine them, right? So we're going to go to a 2 sample. So if you subtract, I want you to kind of think about that. If you subtract values, and the original shape of x is normal or approximately normal, and the original shape of y is approximately normal, and you take each value and subtract those, the shape's going to stay the same. All right, so it's approximately normal. And if you just skip that top box and just jump straight to 20, you'd have to check large counts for both. So you'd have all 4 of those values, right? All 4 of these guys down here. The mean difference, so we could take the mean of 1, and remember subtraction does affect means, so we'd take 0.216, we do minus 0.2, and we get 0.016. The standard deviation, if you remember, you cannot, well, let's kind of look at it. So this is the mean of the p hat of Skittles minus the mean of the proportion of M&Ms. Okay, so you can subtract center. Standard deviation, if you remember, you cannot subtract. So the standard deviation, we're going to take the standard deviation of each, 0.0582 minus 0.0565. And you cannot subtract spread. So this is actually going to give us an incorrect answer. But what you can do, if you remember, you can work with variance. So I'm going to change those to variance by squaring them. Remember, though, when we subtract, we lose spread, and you actually never are going to lose that spread. It sticks around. So we have to add, then we'll have to take the square root at the end. We'll get 0.0812. Now, if you look at my estimate, I mean, I was a little bit off, but not too bad. You know what I mean? Just for a small scenario there where we did it in real life. Obviously, we did not have enough samples, but it does check out, right? So this is the point of this is to show you the relationship between a modified sampling distribution, and then if you know the parameter, you can go through and calculate all these things and know what would have happened for that sampling distribution. Okay, so what do we do with this information? You have questions kind of like 21. So if we calculated a difference between proportions and we got 0.08 when we subtracted them, so I did the Skittles, he did the M&Ms, we subtracted them, we got 0.08. We want to find out the probability that we would get this. So is this, I mean, a typical one or what's going on, right? And so because we know that the difference is approximately normal, we can treat it as a normal probability. So we have 0.016 as our center. It's normal, 0.016, and then if you remember, our standard deviation was 0.0812. And we want to figure out the difference of proportions is 0.08 or higher. All right, so if you remember the next step to find the area under the curve over there, that will tell us the probability that would happen. I'm going to find my z-score, which is my value minus my mean, all divided by the standard deviation, which gives me 0.79. Now I'm going to go to table A, and that will give me 1 minus, and then when I look at 0.79 on the actual table, I get 0.7852, which is about a 21.48% chance that would happen. Okay, so what I want you guys to do is try 22. I'm going to write the answers, but you're going to actually do the work. And then if you have any questions, you are going to email me. All right? So go through, do it, and if you're not getting the same numbers as me, email me and we'll chat. All right, so you have lots of problems to work on today. It's listed in Canvas, but make sure that you're understanding this stuff, and if you're not, let me know.